address in the next 45 minutes or so are what it means to be an architect in the coming years. And we're going to spend a little time predicting the future and then returning back to reality and asking ourselves, what are some of the forces upon us as an IT architect, and how might that impact us in the coming years? Along the way, please feel free to shoot me some questions. You can do so in the chat box, and I will try to attend to them as they come through. If not, toward the end of the presentation, I'll set aside 15 to 10 minutes or so, and we'll be able to attend to them. Predicting the future is really, really hard. In fact, I do a particularly lousy job of it. A number of presentations in the last few years I've been asked to speculate upon the future. I don't know why they especially come to me to ask those questions. I don't have any particular powers of clairvoyance that lead me to understand what the future is, but I do know that when I try to predict the future, I'm really bad at it. In fact, it's not just me, but take a look at all the other pundits in this space. This is from a video that came out, I think, in the 70s that certainly predated the internet, but it was speculation on what our interactions with computers would be like in the future. What I find amusing about this is the first case that this woman would have all this equipment around her in her house, and the second, how microfiche-like the displays were at the time. The scenario goes in this particular presentation is that she would now be able to shop without having to leave the comfort of her house, and well, that's certainly come to be true, but in vastly different ways than I think was predicted here. The basic human need hasn't changed, but the way we've carried it out is indeed very, very different. Another example of how we really messed up predicting the future comes from Blade Runner, the classic post-apocalyptic science fiction show. Of course, I'm still waiting for my flying cars. Being a child of the 50s, where these kinds of things were rampant in the science fiction literature, I'm still waiting for my flying car and my jetpack. Something a little bit more, down to earth, bad metaphor, I guess, of course, is 2001: A Space Odyssey, and of course we've blown through that by about a decade now, and I'm still waiting for my space station. But if you look at this particular image and you look really, really closely in the middle of the screen, right above that middle display in the bottom, I'm not sure you'll see it here, but go look at the movie itself and you'll see the logo IBM. And well, that was certainly wishful thinking because all of us aren't quite as much in space as we would like to. But I remember as a kid watching 2001: A Space Odyssey and thinking, I was really enamored of the show itself, but thinking, wow, it's going to take a lot of software to do all that kind of thing. Well, that certainly has proven to be true. Another example of where we've certainly not done a great job of predicting the future comes in the area of AIs. I mean, the notion of AIs in the movies and books have been rampant since day one. Think back even to the days of the golem as we find in Jewish literature. But we're a long ways off. I've had the pleasure of working with the team that built Watson, and by no means is Watson an AI like this, and we're a long, long way from getting there. Consider another way we've done a really bad job of predicting the future. I mean, go back to the book and the movie 1984, and good heavens, back then we were predicting a society that had pervasive surveillance. It was 24/7 connectivity. The government was intruding upon our lives in a number of digital ways. There was absolutely no privacy, and well, maybe we did get that one a little accurately. Well, okay, perhaps not as dark as 1984, but nonetheless, we certainly have achieved the surveillance society as was predicted back in this book and movie. Well, as Alan Kay observes, the best way to predict the future is to invent it, and I'm delighted to talk with all of you because we are among those who are trying to invent that future for all of us. But what really humbles me in this discussion and really propels me every day is the realization that we are in an industry that makes a fundamental difference to individuals, to families, to corporations, to nations, to the civilization. And no matter how outrageous a future you might imagine, no matter how simple a future you might imagine, that future relies on software-intensive systems that haven't yet been built. And that's exciting and frightening. It's exciting because we are the ones who are inventing that future. It's frightening because we are the ones who are inventing that future. And so, ponder that as you go through, some 2 a.m. debugging strategy, or you get some call in the middle of the night, or you're dealing with yet another round of NA meetings. In the end, what we're doing does really fundamentally make a difference. Norm Cohen observed that in the midst of the IBM work we were doing for the Smarter Planet, there's a dark side to that as well. It is a little bit geocentric in its nature if you think about the Smarter Planet. A little bit of a humorous aside that he has in his blog you might want to take a look at. But it's not so much the Smarter Planet that really worries me about it, it's the stupid people that are populating that planet, which makes our efforts even more interesting, because we are doing things that change the way people live and work and love, and that has a deep responsibility for us relative to the human side of it. As we'll see as this presentation unfolds, what we must deal with as IT architects has a very delicious and wonderful technical side to things, but it also has a very human side to it as well. The question was posed to me in giving this presentation: how does one bridge the gap from being a true leader to becoming a thought leader? And as I pondered it a bit, I realized that's the wrong question in some ways, because the world doesn't need more and more thought leaders. There are plenty of people who think deep and great thoughts. What the world needs more of are people who can create those great thoughts, take the great thoughts of others, and make them real. And I think of Steve Jobs, one of my heroes, who certainly made that manifest. It's not the thinkers, and we do need the thinkers, but we also need the doers, and that is what we are as IT architects, because we're not just the ones who sit in ivory towers and pontificate upon the way we think the world ought to be, but rather we are the ones who help make the world actually that way. And so it is being doers that I challenge us to be, and being doers who are ones who are cognizant of the privilege and the responsibility of doing what we do. So let's step back for a moment, and we'll project forward in terms of the forces upon us in our world. But before we get to the future, let's take a look at the past for a moment. There has been born a digital generation that does not know the internet never existed. And that's exciting, because the great thing about mortality is that it clears the way for those who are the new doers. But it also means that we as an industry, we as a people, tend to have this incredible amnesia of our past. I have a goddaughter who lives across the street from us. We were having a conversation with her about her future and what she'd like to do when she grew up, and she was a little curious about my field. And as we probed her further, she made the observation, as preteen girls are sometimes want to do, oh, she doesn't need to know anything about computing because she understands all of it. She's taken a class. Well, what did you learn in the class? I asked. Oh, we learned how to make a Word document and to surf the web, and so I know everything. Well, clearly she doesn't. The joy of youth is that you do believe you do know everything, but she is of the generation that believes that what happens and what exists in the computing world indeed has existed there since all time. It was perhaps created by God on the sixth day. Not quite so bad, but the reality is the past is not relevant to them. And yet we know, if you're a student of computing, that we have a very rich past. There was a time that computers were human, and as the various economic and human and technological and social pressures weighed upon computing, we can see some very clear ages in the growth of computing. Now, we're in a particularly interesting time, although if you go back to any of these other times, the people there will tell you it was equally interesting. In the time of the rise of machines in the 40s and 50s, we were facing a war, facing several wars. And my contention is that during those time frames, it was indeed many of the influences and the needs that drew us for dealing with warfare that led to the great advances in computing. We saw then in the 60s and 70s the tremendous influence, frankly, of the 60s counterculture. Take a look at the book What the Dormouse Said, and you'll see a wonderful story in there. And Doug Engelbart's creation of the mouse was very much a counterculture reaction to what was going on in the world at the time. And his work and others at Xerox PARC led to a tremendous number of inventions that brought us modern computing. It is the case that even if we move forward to more present times and the expansion of the web, we're seeing some interesting history that influences us today. The web is what it is because of these pressures upon it. In the last decade, there's been a period of retrenchment, thanks to a variety of economic pressures and technological pressures. But that being said, we're moving, I think, to an interesting age, because this coming decade, in many ways, is the age of transparency. I spoke of the invisibility of computing to a whole generation, and it increasingly is so. There are many, many folks who do not know and, frankly, do not care what happens beyond the screen of their iPad or their phone or their Facebook window. For them, it simply works, and that's good enough for them. That's a great thing. The last thing the world needs is more technology, and we as IT architects have this wonderful responsibility of creating complex things whose complexity we hide from the world, and even more so now because, for example, take a look at the Amazon fire, and the places where, and I'm not bashing it, but the places where its technology bones stick through is where you see the most complaints about it. The world wants technology that is like magic in so many ways. In the coming decades, I'll make the, I think, fairly safe prediction that unless some apocalyptic event happens, we'll be certainly in an era of total dependency, meaning that it will be virtually impossible to live one's life without some degree of connection to computing. Indeed, even now, it requires energy to separate ourselves from machinery. I speak of the rise of the machines in the 2030s, not in the sense of the Terminator sense, the rise of Skynet, but rather the reality that we're moving into an age where devices, robotic devices, embedded devices are more and more part of our life. Just take a look at the social pressures and the technological pressures going on in Japan to telegraph what's happening there. As an architect, looking at it from the outside, people view our role as one of the magical things, such as what you see architects of large buildings do. I don't know if you recognize this sketch, but it is one that Frank Gehry devised when he was dreaming this building. And it's not so much the thinkers. Gehry is very much a deep thinker, but it's the fact that he and his company are able to turn these ideas into reality that make his work so interesting. Indeed, I mentioned the Earl below here because he has a software company. He has a company that delivers products that help him manage and build these things, which defy the ability of traditional manufacturing and building techniques to do so. Even in the construction world, software has become a pervasive element. And yet, as Philippe Starck has observed, Philippe's one of my heroes. Philippe, if you haven't followed his work, is currently a professor at British Columbia, and he pioneered a number of ideas relative to the practice and the description of architecture. I think he said it well when he observed that the life of the successful software architect is an ongoing series of suboptimal decisions, often made in the dark and under pressure. This is the nature of our world, and it is both a dismaying and an exciting one, because we are called upon to do these kinds of decisions. We are led in our careers to make the hard calls that others have asked us to do, and yet we must do so in a context where there is no perfect answer. One of the great emotional challenges, I think, of being a software architect or being a software developer is the realization that there is no perfect answer. And indeed, as the old French saying goes, perfect is the enemy of good enough, and we must seek being good enough. Some of you who have seen my earlier talks may have seen this riff, but as I think about the role of the IT professional, it requires you to have the resources of three classic characters, certainly that of Hercules, because you must show your strength, power, and leadership. Now, Hercules, of course, was a little bit different era. His skills were mostly involved dealing with slaying, capturing, or stealing, and I'm not by any means encouraging that of you. But rather, we find that in many ways he was a fearless leader, and we must be that as an IT architect. In some ways, we are also a little bit like Sisyphus. We mostly know the tale of his, of having been condemned to push this ball up a mountainside, this rock up a mountainside, only to have it roll down at the end of the day, and he had to continue on and do so. Such is the nature of the IT architect as well. But if you go into Sisyphus' story, you'll also learn that the reason he was condemned to do so is because he was a very clever person, and he just happened to annoy some of the other gods. So as an IT architect, beware of what you wish for, but cleverness is something that is also rewarded. And lastly, we need the skills of Job, who is certainly very patient and long-suffering. He certainly encountered many trials, but in the end there was his rising. These three things, I think, are great analogies for what it means to be an IT architect. Now, through all of this, and we'll talk in a moment here about the pressures upon us, but to level set it, through all this, we're really talking about systems engineering. And to that end, take a look at what INCOAST describes it to be. Even though we are IT architects and we think most of our focus is upon the software side, recognize that at the very least we are building these things in the context of larger systems, be them hardware systems or be them human systems as well. And this is what INCOAST describes as that system. Now, there are some conclusions one can draw from this more complicated thing. And this comes from the delightful book, Systemantics. It's a play on words. If you say it really fast, it sounds like a really exciting word, systemantics, systemantics, systemantics. But if you break it apart, it reads system antics. And it points out that every system, every complex system, tends to perform in some curious, amusing, unexpected ways. As John Gall observes in his book, everything's a system, everything's part of a larger system, and every system displays antics. You can't predict the behavior of that large system. This is what makes it, I think, particularly fun as an IT architect, because we do what we do. We try to carry out the great thoughts we have about such systems, but we never are fully in control of the systems themselves. This is especially true of web-centric systems, where we are building loosely coupled things that rely upon components over which we have absolutely no control. And furthermore, we are building systems that others use over which they have no control over us as well. It is the interplay of these systems that make them so wonderfully complex and wonderfully fragile. Colossal systems, as a result, foster colossal errors, and we are in an era of building more and more colossal systems. In fact, let me observe the statement that all systems, all complex systems fail. It's just reality. Deal with it. And what I mean by it is that if you look at the work of Kunichi Tanaka, he goes on to say, in a larger context, it's not just engineering software systems, but every engineering system will result in some degree of failure. The key is that all systems will fail, but many of those failures are invisible. Some of them are benign, some are annoying, some are painful, and some are fatal. You can make the analogy to the human body as a system. The human body is a very, very complex system, and at every second of the day there are some failures going on. Happily, the human body has been deliciously engineered over a millennium through evolution to allow it to be self-correcting in many ways. Some of the things that go on are benign. I have a little bump here or there, or I'm bald. These are failures of the system that don't necessarily affect one's daily life. There are annoying ones, there are painful ones, and there are fatal ones. But every system is like this, and it is true of software-intensive systems as well. The way that systems fail is true no matter it be an organic system or one built out of bits. But this is sort of the basics of all system theory that observe that failure happens in a number of ways, and they're consistent across systems. Sometimes a system will fail because it operates outside its design envelope. This goes back to the great Saturday Night Live skit about this one product that was both a dessert topping and a floor wax. It was certainly designed with a very, very large design envelope, but most systems aren't designed that way. And if you try to push them outside their envelope, they're going to fail upon you. Sometimes systems fail because of a direct chain of events. As Feynman unfolded the things that happened with the space shuttle failure, this was a clear example of a direct failure chain. Now, the ultimate causes were systemic, the root causes were systemic, but once the critical factors came into place, there was a clear chain of events. Some systems fail due to the unexpected consequences of its operation. I think this is especially true of software-intensive systems, because now we have built systems that have sufficient complexity that there is, it is truth to say that there is emergent behavior that derives from them. And that emergence comes not just from the software itself, but rather from the fact that we as humans are in coevolution with those systems. Making it even further more complex is the reality that we, in these systems, are building things that have really a fundamental complexity to them that is utterly, completely inescapable. And furthermore, it is that level of complexity that often gets to a tipping point. There are often some triggers associated with them. This is a talk unto itself, but the kinds of software-intensive systems we build all meet these characteristics. The notion of non-holonomic constraints means basically we're building systems that its current behavior depends upon its past history. And as the complex systems we have more and more history upon them, then the opportunities for that complexity to be triggered increase along the way. Now that's the dark side, but on the upside we know that systems succeed in a number of ways, and these are some of the fundamental practices that every architect must have. And the point I'm trying to make is that no matter what future we may observe, there is really a fundamental set of lessons in systems engineering that will apply to us no matter what. We may be enamored of this new technology or that, but the fundamentals still apply no matter what future we may envision for ourselves. Another reality we must consider as we look to the future is that all complex systems are legacy systems, and this is true in every system that I've encountered. I could riff on every one of these, but most recently I riffed upon the future of Facebook. If you go to my blog at the handbookofsoftwarearchitecture.com, I had a recent posting there about Facebook's future. I mean, right now they're sitting with a code base. It's a few million lines of code, largely in PHP. And as you see them growing, and now they're moving across, they're setting up a large office on the East Coast. The reality of that is that they're going to face some architectural governance challenges. And while it makes sense to have startups begin with rapid innovation with a few developers in a room, indeed the first version of the Facebook was running on Mark Zuckerberg's laptop and only a few thousand lines of code. To turn that into an economically viable platform requires the activity of a number of people, and as a result, architecture does start playing a role. It'll be interesting to watch what happens there. This is something that Google has been struggling with. So the reality is that the moment you write a line of code, it becomes legacy, and you must be faced, therefore, with the things you can do with it. And there are a variety of them. I won't go into the details here because I wrote this up in an article for IEEE Software. If you follow my column on architecture, go back and look at the podcasts and the articles themselves, and it explains it. But the point is, as an IT architect, we are never dealing with brand new systems. By the time architecture becomes relevant, there is some amount of legacy that we must deal with, and that legacy means that we must deal with the inertia of change. And as we move to the future, as we look in the next 10 years, it's not like that legacy is going to go away. If anything, even for the Facebooks of the world, you can see that the amount of code we're dealing with grows and grows and grows. So the exciting thing is, as I often say, developing these kinds of systems has been, is, and will remain fundamentally hard. No matter what future I can predict for you, this is the reality of what we do. One thing I can do, though, to help us understand that future is to consider the engineering forces upon that future. I'm a great believer in the notion that developing software-intensive systems is an engineering activity. And as an engineering activity, it means that we as architects are tasked with building systems that reasonably push back the forces upon us. And those forces may be both static as well as dynamic in nature. Now, from a very general perspective, and I'm looking at the forces upon the systems we kind of build, there are a number of things that impact us. There are technological forces, there are economic forces, there are societal forces. So let's spend a few minutes on each one of these and ask ourselves, what will weigh upon us in the next 10 years? And then we will examine, knowing those forces, what do we do about it? From the technological side of things, one of the things that hits us up front is the fact that we have the end of frequency scaling. What I mean by this is that in the latter years of Moore's Law, the way we're able to get greater performance is by cranking up the frequency of our devices. And we got great performance over time by so doing, but we're not going to do that anymore. We're reaching a point of diminishing returns. And the reason we're reaching diminishing returns is just the pure physics of it. That as we scale things up, it means you're shrinking things closer and closer. We're now able to build devices that have a transistor on the order of about 100 atoms, and we see a path to get it to a transistor around 10 atoms. In fact, it's even getting better because we're seeing now at the level of quantum computing the ability to produce qubits, which are at the subatomic level. So once you start squeezing things down that tightly, all of a sudden you've got to switch over from unit processors to multiprocessors. And that's why we've seen all the major chip manufacturers do the shift to multi-core systems. It has to do because ultimately we're bumping against the laws of physics, and so the guys in the physical world say, oh, can't deal with it anymore, now becomes a software problem. And that is a reality for us as IT architects. Now, for the most part, a lot of that concurrency is hidden below the surface. We deal with the web, which is inherently itself massively parallel. But as we move things to physical machines themselves, for the most part, our operating systems and our middleware accommodates us. Take a look at how Intel has done it with their concurrency design patterns. Look how Apple has done it with Grand Central, which is a great way of hiding or giving an abstraction of concurrency and letting developers build things and not have to worry about those details. So that's the good news, but the bad news is that concurrency is in the future for all of us. Another reality that we must face, and one of the technological forces, is frankly the death of operating systems. I'm not saying that Linux is going away or Windows is going away, but they are no longer interesting relative to being the most major force for us in how we build systems, but rather it is the rise of platforms that are more interesting. The web is certainly a platform which has led to the presence of things like Linux and Windows as being just part of the plumbing. So what's happening is this shift of the rising levels of abstraction, which is the way we historically have dealt with complexity, and it means now we have things such as AutoSAR that one builds against, the consortium of companies led by BMW to provide a platform for in-car electronics, or the platform called MASAT, if I pronounce it correctly, which is an attempt to build a hardware-software platform for marine systems, boats and ships and yachts and the like. So this shift is happening everywhere, where you see an economic center, dominant design, if you will, that leads to the bringing together of people who realize if we develop standards in this space, we actually grow the marketplace for us and stabilize it. That's what's happened in AutoSAR, and we're seeing it in other places. And that's why I speak of the death of operating systems, because they're just part of the plumbing of these platforms and the rise of these domain-specific platforms. Now, another good result of this is that, and this is sort of the nature of the evolution of complex systems, is that we see the rise of loosely coupled systems. The web is a clear example of that. And in those, and the creation of standards such as HTML5, the various standards for communication across the web as well too, both the low-level protocols and the high-level protocols, is an instance of how we have evolved to these standards that allow us to build systems that are nearly independent with one another. And here I'm using the terminology of Herbert Simon, who speaks of this kind of structure in all complex systems. The other pressure that this is leading us to is to the growth of the Internet of Things. The move from IPv4 to IPv6 is one of the implications of the Internet of Things, because who would have thought that doorknobs are IP addressable? Who would have thought that cars are IP addressable? But that's a reality of it. And so with things like the car as a platform, the cell phone as a platform, the tablet as a platform, and not just that, but the many devices that populate our world that require no human intervention and are speaking to us constantly, this gives rise to a very rich primordial soup into which the IT architect now works, a much richer soup than which we had in the past. There are also some economic forces upon us to which we must attend. One of these is the notion of population growth and the resulting demand upon energy resources. Rule of thumb says that if you do a single Google search, it'll cost you the energy equivalent of boiling a cup of tea, which is quaint and charming and comforting. But if you start multiplying that by the billions upon billions of searches that are done on a daily basis, then all of a sudden we're talking some real energy. Depends upon who you talk to, but somewhere around 10% of the world's energy costs are currently dedicated to feeding all of the computers that we have. And you know, think about it, just the growth that has been in our world in just the last generation. One of the other implications of the population growth is also the population shift, the demographic shift, and this is why I telegraph what's happening in Japan, where you have actually a slowing population growth. In fact, it's not even clear if it's replacement growth in Japan, and it's true in most industrialized countries that we're reaching that place, but also a shift to an aging population as well. This is one of the reasons that's fueled the growth of robotics, if you will. Another reality of it is the scarcity of key resources. We think of oil shortages, but one must also deal in our world of the shortages of rare earth materials, and that's why discoveries in places such as China and Afghanistan and South America, some of these rare earth things are cause for celebration because we need them for the chips we build and the displays that we have. Another issue of these that's really an economic force is the fact that we are led to building distributed systems. The fact that energy costs are high, transportation costs are high, is leading to people not moving as much as they do, and that's the nature also of just the current economic malaise. But yet software development happens, and because of these economic forces, we're seeing more and more distributed systems and distributed development. The other reality of it is that with more and more people depending upon software-intensive systems, it means that security looms very, very large upon us. And that leads us to the human side of it. I've alluded to the notion of the implications of the birth of the digital generation, who cares less about the guts of the technology. They simply want to use it. It has also meant there is the tremendous rise in the copyright and patent implications of what we do. It used to be, as we developed, we didn't think at all about copyright issues because these things weren't copyrighted or patented, but now they are. And for most of us, we often have a legal team a phone call away to help us as we proceed. Didn't used to be the case, but we have to deal with these kinds of issues as even IT architects. Whereas security was an issue I mentioned now, it's also privacy becomes a societal issue because we are building systems for which we are impinging upon human privacy, individual privacy. We are building things that have the potential of really a pervasive surveillance society as when in 1984, and that means we need a dialogue at the human side of things. There are things that we know we can build as IT architects that perhaps we should not build. The other reality is that we are building systems because of their inherent complexity. They are inherently fragile as well, and therefore the stakes are higher. That is why I observe that in the end, software development is a moral decision, that what we do on a daily basis has implications for societies, has implications for the civilization and individuals, and therefore what we do is something that we just can't say, well, it just seemed like the right technical thing to do, but it does have implications. Now, those are the pressures upon us, and the point I want to make here, and I want to wrap up in a bit so we can get to some questions, is the reality that we're in a world that hasn't changed that much, even though the society around us has, and the technology underpinnings has, but in the end, we are trying to take a vision of what we'd like to do and to turn that into reality, and the things that keep us from that haven't changed and won't change. There are some things that we know are fundamental. The laws of physics aren't going to change out from under us, and at the other end of the spectrum, we're not going to be limited by human intelligence as long as there are humans around. What I think the IT architect must most commonly deal with are the problems that are very much in the middle, the problems of design and the problems of organization. What I mean by that is that we have a delicious problem that's on the cusp of the technical and the social. To recast it back to the forces, it means that we as IT architects must deal with these static and dynamic forces on a daily basis. So earlier we were looking at the grander forces at the societal level. This is what we must deal with at the project level. There are some of the obvious business forces, cost, schedule, and mission, and the like. There are the development forces. Where are my people? Do I have enough of them? What are their skills and the like? The environmental resources deal with, in many ways, issues of legacy. When we speak of compatibility, it's not just compatibility of standards, but also compatibility with existing legacy systems. And as I alluded to, there are also forces in the area of values, the legal and ethical and moral issues that weigh upon us. To that end, systems are shaped by a myriad of design decisions weighed in by these forces that different stakeholders have, and your goal is to balance those forces upon us. That's why I think as you project forward what it means to be an architect in the coming years, think about the forces that will weigh upon you individually and societally, and ask yourselves, what can you do best to weigh upon those forces, and what can you do as an individual to gain the skills sufficient for you to build systems that optimally attend to those forces. Now, a few quotes that go along the way here. Eberhard Richten has observed that as a software engineer, or as an engineer itself, really you're dealing with measurable kinds of things. This is what delights me so much about Agile practices, because they rely upon, at its essence, rely upon measurable deliverables. I had the wonderful opportunity to spend time with the team that built Watson, the project, the system that beat Jennings and the other human at Jeopardy. And I think one of its keys to success is really twofold. One of which is they had a team that worked in a war room and did regular builds. And the most important one is they had a set of measurable results against which they could test every deliverable. It turns out that there's a thing called JArchive, which is a repository of every question and every game played publicly in Jeopardy, and that was used as an example to measure against those releases. And this is entirely consistent with what Richten observed. So as you move forward in these coming years, ask yourself, what can you do to quantify the results of what you do? Krusten goes on to observe that as an architect, it requires, these kinds of skills. You need some experience. Architects just aren't born, but they grow over time. It does require the leadership, like we spoke of Hercules. And this one's often left out, but I think Philippe has it right, that the best architects I find are also great communicators. They're able to take very, very complex ideas and translate them to bring others to action. Richten goes on to also observe, and I finally offer a reference to his book, that he didn't call it this, but it's very much the notion of Agile practices. If it works and it's useful, that's very, very pragmatic as an engineer. And he also observes that one should attack risk. As an IT architect, what I'm encouraging you to do, therefore, is to be very proactive, be very intentional about ferreting out and attacking the risks you find within your systems. Steve McConnell goes on to note that as an architect, your job is to provide an elevated goal, and he has it through this wonderful example of digging ditches. This is true of an IT architect. You will be in a role of inspiring others, and part of what you must do is, even in the heat of battle, to keep your eye on that elevated goal, whatever it is, and communicate that to the others with whom you work. These are a few of my favorite books that fit within this space. You've probably heard me speak about the notion of the best practices of growing in architecture. My influences that have led me to that are not just the work I've done in this space and people like Philippe, but also go back to look at Herbert Simon's book, Stuart Brand's book, the book How Buildings Learn, and then another one you may not have heard of, a book called Unbuilding Cities by this delightful woman from Europe who has done a study of urban renewal. And the reason I find it interesting is because software development is very much like that. Ken Orr has some recent riffs upon this. For simple systems, it's like building a doghouse. You don't need blueprints. For other kind of systems, as the risk gets higher, you do need blueprints, and you need to organize a group, and you need power tools. That's, building houses. But if you're starting to build things that are high-rises that begin to stress the technology and the society around you, then it requires a tremendous amount of engineering skill. Given the presence of legacy systems, and given the reality that we build systems that are invisible to the world and yet pervade our society, the IT architect's role is very much like systems planning within cities. And that's why I lead you to the book Unbuilding Cities, because we build systems that live within part of a city. Some of us, are able to devise where the roads are. Some of us set the standards for what buildings should look like, or the wiring standards, the plumbing standards. Most of us build buildings, and we try to do so in a way that is harmonious with the world in which we build these kinds of things. Now, in building these systems, we know that we sometimes have unprecedented systems we build, and that requires a tremendous amount of intuition. For the most part, though, we are building systems that are classic and repeatable variations upon a theme of previous ones, and therefore we tend to steal a lot of what we've done. And I'm not saying in a way that violates patents and copyrights and those kinds of things, but the reality is that we apply the practices of our design patterns and our architectural patterns and subsystems that we've had from previous systems that lead us to the system we build now. This is why architecture is important to me, and this is why, I'll do a brief riff on this one. This is why architecture, I think, is so key to the future of the kinds of systems we build. My definition for it is simply software architecture is a set of significant design decisions, and managing those design decisions is fundamental to the success of the system, because all systems architecture is design. Not all design is architecture, and it's the significant ones that really define the load-bearing walls. It's the plumbing standards and the electrical standards and where the roads lie that set the framework against which all innovation happens. The thing that one must keep in mind is that at the bottom, it still is all bits, but at the top, it's the fact that we must deal with the humans who build these things. And that's why, as an IT architect, that even though technology is growing for us over the coming years, what's growing for us also is the societal and human impact upon what we do. And so it is why we must have this dance between the human and the collaborative that keeps us going. From the perspective of the architecture side, I'm a great fan of Philippe Starck's 4+1 model view. It's what I've used for documenting and managing all of the systems that I've encountered over the years. Indeed, it's the pattern I used in describing Watson's architecture. And even for an AI system, this works, and it really, really does work well. But I know that as an IT architect, it requires us to apply energy to make these complex systems simple. One of the trends that is inescapable for us in the coming years is that the systems we build and the systems we interact with are becoming increasingly complex. And it requires us, therefore, to push back the tendency toward unbridled complexity, disorganized complexity, as Simon speaks of it, and we do so by applying energy. This is why I urge you to bring the notion of patterns languages into your vocabulary, because patterns give us something to which we can refactor and bring us to greater simplicity. Now, simplicity is not just a good idea, but it also has economic sense. If you look at the Kokomo 2 model by Blast, his name just popped out of my head. It'll come back in a moment. I'll start a background process. Barry Bain, there we go. Barry Bain's work on Kokomo 2, and this is a simplification of the Kokomo 2, but it observes that the greatest impact upon project performance is complexity, and so whatever we can do to attend to that complexity has the greatest impact upon the performance of our project. That's why refactoring is such an important thing. In the end, though, it is what we do as IT systems as a human activity. And to achieve this, it means that we really have to have a strong vision that's cognizant of both the technical as well as the social, and dealing with the fundamentals in our execution, no matter what future we might envision. And as we think about that human experience, it means we must attend to the problems of organized labor. The reality is of the human experience of we build things with shared stories, and there's a tribal memory, and there are rituals we go through. Scrum is a ritual in some ways. But ultimately, it is all about trust, that even in the presence of distributed systems and distributed development, the way you gel your team is by growing your trust in those teams. And it's not just through pure, sheer technological delivery, but it's also reflecting the human side of that connectivity, and it means creating the opportunity for serendipitous connections so that you can continue to grow and strengthen the bonds of that trust. So moving toward the fundamentals of the human side of it, remember what Cope has observed in organizational patterns of agile development. Development takes place at two levels, both architecture and implementation, and therefore I urge you in informing your practice to go back to his organizational patterns, because I have seen them time and time again for successful organizations who have built their organization to be a hyper-productive one. These are the kinds of practices that appear to be very, very useful in gelling your team, and I believe they will be sound for us for the coming 10 years and beyond. So again, no matter what future you might envision, the fundamentals never go out of style. Always remember the importance of building crisp abstractions, having a clear separation of concerns, a balanced distribution of responsibility, and pushing towards simplicity. This is Systems Engineering 101, and we are indeed building these kinds of systems. In the heat of battle, you'll ignore them, but as you press forward to that future, always go back to the fundamentals, because they will serve you well. They will ground you. In all of this, too, as you consider your growth over the coming years, take care of yourself. And as an IT architect, this means that we must be responsible for our own growth as well. Don't panic in the face of the pressures upon you. Learn how to delegate. Give yourself the space to recharge. Give yourself the space to innovate as well, too. Software development is important, but being fully human is also important. And you're going to be a far better IT developer and IT architect if you also attend to your human needs as well. To that end, as I alluded to, it's a tremendous privilege to be a software professional. It's also a tremendous responsibility. Now I'm going to open up for questions here in a moment, but I wanted to attend to something else that I'm on a journey on that I wanted to give you attention of. I take this very seriously, that it is a privilege and a responsibility, and I'm also humbled by the notion of my goddaughter who doesn't know or care what happens beyond the screen of her computer. To that end, I just wanted to give your attention to a project that we've been unfolding the last 4 years and now coming visible with it. Go to this website, but basically, if you remember Carl Sagan's Cosmos from some years ago, we're on a journey to do a similar kind of thing, a multi-part series for broadcast on computing, trying to open the curtain to the general public to what we're up to. So go visit our site. Here's what we're trying to do to this world, and hopefully inspire a generation of folks, much as Sagan did, to the matter and the mystery of computing. There's a Kickstarter project we have related to this. We've got a little bit of an effort going on there, and would love your time and attention in circulating that to your circle of influence. So this is where we are. I'm very excited about being an IT architect, being in this profession. This is a great time to be in this world because we do make such of a difference. I think we can open up to questions now. I've got about 7 minutes. I do have a hard stop on the hour, but any questions? Raise your hand and we'll get them answered. It is a very quiet group we have out there today.
Okay, there's one question. Tom Thomas has a question. I'm going to unmute you, Tom Thomas.
Hello, Tom.
Tom? Okay, he sent his question through the chat window. He is asking you, Grady, if you can tell the chapter leadership a little bit more about how they can contribute to the your project, Computing the Human Experience.
Oh, thank you, Tom. I appreciate that. Let me go to a slide here again. And bring this back up. I think you should see that now. Go to the URL below, and there is a little widget to the right-hand side about a Kickstarter project that we've launched. There are a number of ways you can help us out. Above that little Kickstarter widget, you'll see a button that says Contribute, and there are a number of ways. Kickstarters are our most immediate need. We're trying to launch a lecture series coming up after the first of the year. We're going to do some Ask Grady videos, very much in the spirit of the Khan Academy, answering some basic questions to the public about computing. And you can materially contribute in that way. You can do so through the Computer History Museum, and we're also, seeking volunteers to help us in a variety of places. There's a lot of research and such that we could use some help with. So, Tom, thanks for asking the question. But yes, go to the site and go to the widgets on the right side, and you'll get your questions answered.
Okay, are there any other questions? We have about 3 minutes left. Okay, looks like Renato from Italy has a question. Renato, I'm going to unmute you now. Renato?
Hello, Grady. Would you tell us something more about patterns and future about architecture? It seems related to many points you introduced during your presentation. Is it right?
Yes, very much so. I'm a great believer in the importance of patterns. I'd urge you to go visit the Hillside group. I think it's hillside.net, if I'm not mistaken, which is the center of gravity of a lot of the interesting work going on in patterns. And really, the patterns community has grown a long way since the days of the Gang of Four patterns, and there's a vast literature in this space. I contend that all complex systems are full of patterns. In fact, Herbert Simon's work emphasizes that as well. And therefore, patterns are important to me in my practice. On the one hand, they are things I keep in mind as I design that I want to build something like this pattern, but they are things that I also refactor too. There's a delightful book called Refactoring, which makes that point quite well. What the literature is starting to grow to is an identification of architectural patterns. To that end, go look at the book titled Software Architecture by Mary Shaw and David Garland, in which they identify some dozen or so architectural patterns. The work we're trying to do with the Handbook of Software Architecture is an attempt to study 100 different systems. We've done archaeological digs on close to 40 of them right now, and step back and identify and name the major design patterns that fit across those systems. It also goes back to Philippe Starck's 4+1 model view that we speak of design patterns like layers, and reality is those patterns really fit according to specific views upon a system's architecture. So to recap here, go to the Hillside group as a source of information. Go reread Philippe Starck's 4+1 model view paper. Go read Herbert Simon's book, The Science is the Artificial, and that'll be a great launching point for you to get a grounding in patterns.
Thank you, Grady, very much.
time for maybe one more question, then I have to move on.
Okay.
Looks like none may be forthcoming. So, thank you all very much. I mean, my goodness, Italy, what time of the day is it there? Thank you for foregoing sleep and joining us here today. Thank you.
Thank you very much, Grady. And I want to invite everybody who is on this call to the next presentation. In 3 minutes, Paul Price is presenting on Iasa's positioning. So I hope I see you all there. Thanks, Grady. Bye.